Today we talk about experiments like giving an elephant a ton of acid. Okay, maybe not that kind of experiment, but experiments. There are a few key bits we should probably talk about, and throughout these lessons I'm going to try and give you as many examples as possible. The statistical inquiry cycle is the structure for most, if not all, statistical investigations that are carried out in New Zealand schools. This follows 5 different parts: problem, plan, data, analysis, and conclusion, or as students like to call it, the PPDAC cycle. I will give a brief overview of all the chapters in this module. If you're looking for specific information for any one part of the cycle for designing experiments, then you can go have a look at those chapters separately. Chapter 2, beginning with a problem. In experiments, we start with a problem in the form of a question. This question will be about a cause and effect relationship. A hypothesis is a guess as to what might happen at the end of our experiment, and usually it's contained within the question that we ask. So, what will happen when you give 297 milligrams of pure acid to an African elephant named Tusco? Spoiler alert, died. Of course, the scientists involved had a much more elegant way of communicating these types of tragedies. As reported, elephants, quote, are highly sensitive to the effect of LSD. So we have a causal question, and then we should also have, in addition to that, a hypothesis where we guess what the outcome of the experiment will be. The next thing that we will do is plan on how to conduct the experiment. In Chapter 3 and 4, we have planning the experiment. It is probably easier to think about the holistic points that need to be covered, the 4 W's: what, who, where, and when. After this has been established, we need to add the big one: how. Typically, this is the longest part in the entire experimental process. We have to plan very carefully, because if we don't plan carefully, we'll get garbage data. And if we have garbage data, we have garbage conclusions. Then it is time to conduct our experiment. During this time, experimenters are conducting what they had planned, creating, recording, and storing data, and also recording notes about whatever is happening during the experiment. The notes recorded during an experiment are really important because we can always refer back to those if something happened in the experiment that we weren't expecting. We're human. Sometimes we mess up. Chapter 6, appropriate displays and analyses. After the experiment, the data goes into a spreadsheet. We run it through a computer program, and finally generate some graphs which are easier to analyze than text on a table. Chapter 7, probability and re-randomization. It involves looking at the chances that the measurements taken during the experiment could have happened simply by chance. There'll be more on this later. Getting re-randomization correct in the experimental process is absolutely crucial. The reason for this is that it will be the evidence that we use to determine whether or not our treatment had an effect, or if it didn't have an effect. Chapter 8, communicating findings. In this part, we summarize the experiment. Each of these chapters will have a more detailed description about each part of the cycle. This investigation is divided up into 5 set pieces. First, we have a question, or a problem, for which we would like to get answers using data. Second, we have to devise a plan to collect good quality data that will provide us with an answer to this problem that is as clear as can be. Thirdly, we will collect the data by conducting a well-designed experiment. Fourthly, the data will be converted from a spreadsheet to visuals that make our comparisons of key features a little more obvious. And finally, we hope to make an inference or a conclusion based on our data. Next lesson, we will discuss the beginning of an experiment. Thanks for watching, and I hope this helped.